Well, this is awesome. I thought I was live a second ago, but we can do all this over again. Let's just walk through it. From the top, everybody. From the top. I have myself. Hi. Again, I'm new to this thing, but we'll get there. So first thing I'm going to do is I'm going to stand up a cluster. So I will share my screen. And I just deleted the cluster, so we should have Tanzu. Should be empty. Cool. We're going to create this cluster using Calico. Let me bump that up. We're going to use Calico. We have to do that now. I think it's going to be the default here pretty soon. But while that's standing up, I'm going to jump back over to the demo that we showed on Monday. And I'm going to, just clean that up a little bit and do a quick walkthrough of that. So this is just a dataset util that I was using to demonstrate how easy it is to kind of switch between data stores. I just got off with my buddy Greg Green talking about you have a lot of options. A lot of times you have a lot of options on the menu, and sometimes it's hard to figure out which is the right option for what you're trying to do. So in this case, this demo really it just sets up a REST controller. So we'll look at that first. This REST controller has a method. We'll focus on just the loading. The method one is loading to Redis, and the other one is loading to a JPA backend. So here, what it's expecting is that there's a Redis implementation up and running, and also that there's a JPA version. In this case, I was using Postgres. And what it's going to do is it's going to load a CSV file. CSV file, still pretty common. We'll take a peek. The CSV file is 6 megs, 6.75 megs. I don't remember how many rows of data that is. Let's see if we can take a peek. But yeah, 6 megs, not huge, but not small, right? It's not something that's going to finish in a second. So this is what the example is for. It's going really, really slow. So 2 options using the CSV loader. The CSV loader that I chose, I'll jump over to my dependencies. I just upgraded to this fast CSV version 2, and that's where a lot of the work that I was doing, a lot of these changes are upgrading. The last time I was using this, it was 2.4.5, and we're just going through the steps to upgrade. And this is what it looks like. I also upgraded from Java 11 to Java 17. But this is the fast CSV loader. That's the library that I'm using. Actuator, data JPA, data Redis. And I'm also using test containers. I use the latest version test containers. So we have a retail store controller. That controller's got two endpoints that we're worried about right now, the load Redis and load JPA. The data, I created a base image or a base object, and that base object looks like this, where it's got basically a element for each column in that CSV file. So I see country, operation type, establishment type. We'll see that those are the same. Country, operation type, establishment type. You see I skipped over license number because that's the difference. So for both of these backends, the JPA data store and the Redis data store, for both of those, they're using this exact same base object. The JPA one, it's extending from that base object, and we're adding an entity annotation, but for that, we need this ID. So we're using an entity annotation along with this @ID annotation on license number, and that's how it's going to identify each row in that data set. On the Redis side, we are using a Redis hash. It still has an ID, but it's still extending the base store, but it's storing it in a different model, storing it in a different data store. So those are the only differences between the JPA, where it's an entity, and in the Redis hash, or the Redis version as a Redis hash. Everything else is the same. I just got to just clean up. So hopefully that's clear. Let me pull this up over here. I will try to keep an eye on the chat. If you got questions along the way, feel free to ask. So that's the demo. That's the data. And then for storing that data, I use a repository, and this is using a CRUD repository. In this one, it's just grabbing the store JPA. So this repository knows to use this object. That's the JPA object. And the same on the Redis side. It's just using a repository with a different data model. The CSV loader, then, it's going to read those data, or read the data, the CSV file. It reads it into a list. And then from there, I've got two methods. I have a Redis method that's going to grab that same list. These look the exact same, where it's taking that list data and it's reading it into rows. And then from there, it's looping through. So it's not the most efficient, but this is just an example. It's going to loop through each row, and on each row, it's going to convert that row of data into Redis or into that JPA. And those, again, look very similar. So converting to Redis, I've got each of my columns, and I'm just using a builder. Same on the JPA side. Exact same for each column, except one's the store JPA builder, and the other is the store Redis builder. Everything else is the same. So as similar as you can be on both sides, that's all of this demo is doing. It's showing both sides. This is what it takes to store it into Redis. This is what it takes to store it into a JPA. It could be MySQL, it could be Postgres or other, anything that follows that JPA model. So here's what we're doing. It works. We test it. Oh, but I didn't stand up the instances. So let me see if I can remember how I did that. Yeah, there we go. Let's do a Docker. We're going to stand up the Postgres instance. Didn't need to type all this out. So that's creating it's a container running on Docker that has Postgres in it. We'll do the same thing. Run different ports to the defaults. We're exposing it so that our application, can connect to it. So now I should see not just Postgres and Redis, but I'm also going to see that cluster that I created earlier. So cool. I see Redis, I see Postgres, and then I see my cluster node. So cool. two different things. So let's scoot back over here. So my cluster is done. So what we're going to do next is part of this project. I'll show that real quick. Part of our project over here gave us this super cool one-step install, and that's what I want to show. So here's the project. One of my favorite teammates in the world. Yeah, it's for running TCE local, and it's just a really quick, easy way to do it. You can take it any way you want. This example just includes monitoring. So you have Prometheus and Grafana just out of the gate, along with the other dependencies that it needs. So it kind of walks you through, hey, here's how you stand it up. It does change the CNI, but then it shows you all the steps in order to install all of those packages. He's made a custom repository to store some of these packages that he's made. They are just pre-configured to run on your local environment. But you can walk through all those, but you can also go down here and it gives you the command to just say, hey, I actually gave you a Kubernetes deployment that you can just apply. And that's this guy here, TC local install, and that's all we're going to do. So we're going to apply that guy to our local TCE deployment. That's going to take just a second. Package. It'll take just a second to reconcile, and then we'll come back. So our demo over here, we're going to run it. NW spring boot run. And I just had a thought of, is there anything in here that might be difficult to run as a native compilation, other than the fact that the native compiling takes time? So my application is up and running. So I'm just going to capture a couple of those notes. Because these are the steps I don't want to take, right? Until we do our so cool. It's up and running. And then what I'm going to do is I'm going to do the timer. I didn't capture which port it's running on. Oh, it's running on 8080. Did I change that? Oh, I did. So it's running on 8080. Cool. And we're going to do this. We're just rerunning it just to make sure it still works after all the updates that I made since Monday. So localhost 8080 slash load Redis. Going to a little timer here. I'll move the other one first. Load CPA. Tell them head start. And then on another terminal, time pro load dash Redis. So those are both running. And again, it's 6 megs and it's doing it a very slow, or not necessarily slow, but it's not doing anything fancy. It's literally stepping through each row, converting that row from CSV into these domain objects, and then storing those one at a time. So no efficiencies added, but it's doing the exact same for both. So while that's running, cool, we'll make sure that works. We'll hop back over and check on our cluster. That's still reconciling. So it shouldn't take too long, but again, I'm running other services and doing a boatload of stuff. This isn't the beefiest machine. So we'll just wait for a sec. The whole point of this, full transparency, I worked for Redis. And yeah, this was just an example showing, yeah, one of these things is a little bit faster than the other when you're doing writes. So the conversation I just had with Gregory Green was about all the different kind of flavors, all the different types of backends that you have to consider as you're moving things towards production. One of the things that we do a lot is we go to start.spring.io, we pull some things down. And a lot of times we're using H2. And now that we have test containers, we can do a little bit more. But having these clusters and having things available that are easy to stand up and easy to shut down should make some of what we can share and some of what we can do a little bit more advanced, a little bit more real, closer to what you're going to be doing on your laptop. And that's where I'd like to get to. I'd like to have this example of, hey, it only takes a couple of minutes to stand up a cluster, and I can deploy what I need to fairly quickly by doing a kubectl apply and have the things that I need in order to run. So I'll be exploring that a little bit as well. I'm just checking back in on my install. Maybe I was doing a little bit too much. Getting there, no, it's not making any progress over the last time. So maybe I bit off a little bit more than I should have on this, doing two things at once. But again, this is code. So the idea is I'm just showing you as much as I can behind the scenes. And as an example, I like to pair program. And this is fun for me to watch. I enjoy watching the show, watching the others on the team walk through how they're doing things. How are they thinking about things as they're running? Typically, when it's me, I'm going to be running into problems, and I'm going to, get stuck. And then that's the fun part is figuring out how to get unstuck. I don't want to cancel either of these because we don't have super long. I'm making a lot of progress on this side. I do want to get this is the minimum. I want to get this out the door. So I'm going to do that first. So let's go, and we're going to create this repository. I don't think it exists yet. So we're going to create a place to store, what should we call it? I called it a dataset util, but it's not really. It's just a Spring data and Redis. Let's get to data both Redis and Redis. Cool. We'll create that repository. And it's still running, but I think what I can do here, oh, it's already been initialized. Maybe I did create a repository for it. Yeah, so now what I'm going to do is inform the instruction. And then also I split between Linux and Mac, so I always get the control and command split. So then we should have a repository. Cool. Are we, let's make that Docker compose. Why are these still running? It really is taking a really long time. Okay. The Redis load took 5 minutes. So yeah, my computer is very overworked. The Redis load took 5 minutes, but the one that we started first, the JPA one, is still loading. So it's still one at a time loading that 6 megs into that Docker instance. It's on the same machine. It's on the same everything. It's just taking a little bit longer. So let's do this. This is and if we need to do should our Docker compose do both or just one? I'm going to go and grab an example because I don't know how to make a Docker compose file out of thin air, but I have an example. Somewhere. So let's try this. Throw that in there. I'll get rid of all this stuff we don't need. I'm making a Docker compose file that I can. Should I use Redis mod? I don't think I need to. But it'll work. So we'll just leave that in there. We don't need the fauna. Links. Concourse. This was all. Oh, there's a Postgres. So let's just do this. And so what this will do is stand up Postgres. I think I can even go. Yeah, it'll pick whatever's there, but it'll grab the latest if you don't have it. And then the things that we're passing in are the exact same things that we were passing in over here. Was the Postgres password. It's the only thing we need to pass in. So we can remove defaults for everything else. And then here we're going to use the Redis mod, which is okay. Do I need to give it the volume? How are we going to run all this? We're going to switch. We're just going to do Redis. We also have to do those ports. Be exposed. Let's go take a look. It's already running. I'm going to do this. YAML. And we'll see more of that when we move this over to a Kubernetes deployment. And I think that's it. So as soon as this finishes, I just want to make sure that it finishes. I assume it's doing all right. We did our commit. Remember, the other one took 5 minutes. This one's taking a little bit longer. Check our packages. Yay, okay. So now all of our packages are reconciled for our Kubernetes deployment, TCE local. Yeah, let's go take a look at that. So what that's done is a bunch of stuff. And part of the magic of this repository, this particular repository, is that he had set it up for us. Oops, not that one. This one. So that we have a local domain that we can go and hit. So I can go take a look here. Prometheus is up and running locally. Again, this is part of the deployment that we ran against the TCE local using the latest version of Tanzu Community Edition. Pretty cool. And then I just want to confirm Grafana. There should be a way to do those certs, I think. Maybe. Which is getting the things that you expect to have out of the box. It's kind of a neat idea. So let's hit this. So this is metrics from my Kubernetes cluster. And the dashboard just automatically installed. We can see, yeah, we're a little hot, hotter than normal. I'm just going to stretch this out 30 minutes. Wonderful. And then there's another dashboard included automatically, the Kubernetes API server. So make sure you get time, last 15 minutes. Cool. I'm seeing stuff. Everything looks to be working and sending metrics properly out of the box. So I'm pretty happy with that. It's 2:35, so that means 20 minutes into what I was doing. And it probably would have been faster if it wasn't doing these other loads. So cool. The Redis one took 5 minutes. This one took 13 minutes, but we were doing a lot of other stuff on the side. And I've got a slow computer. So I'm happy with that. So now what I'm going to do is I'm going to stop those. I'll stop everything. I'm going to kill the images that I stood up using just Docker. I'm going to do Docker stop Redis. And then I'll do Docker. How do you say that? Can I name it that? Shut it down. Remove it. And the same thing for Redis. ID. And I'll remove it. Now I should only see my node, which is good. So now the next thing I want to do was I want to make sure that this Docker Compose works, so that my steps will just be Compose. Docker Compose up -d is the idea, and then it should be this. has the get started. So let's see if that works. Is -D, fingers crossed. Let me fix my naming. It creates a network. It's cleaning things up. Yes. Its name ports. Excellent. And then I should also be able to do W train run. Excellent. It's running on port 8080. And then instead of doing the loads, I'm just going to do localhost the 80. Get it running. And I close all the management endpoints. That's really good. So now I'm comfortable saying, hey, is there anything else that we should do here? Is there anything else I should do on this example before I push it out there? Maybe explain. Bye. Oh. I think we can call that good. So we'll hit that. And really, this is just a share to make it easy for others. And so the other thing that I was thinking was maybe I want to create an image out of that so that my Docker Compose could, not have to do the run. I could just, hey, go and have that image. Maybe I want to deploy that image to Kubernetes. So let's just take another step of just stressing like, hey, the image is the new artifact. Thank you, Cora. And let's see what it takes to add the steps. I don't think actually we need to add anything. If I just do, I think I get out of the box. Spring. I need the plugin. I know what it's doing. So yeah, this is going to create a Docker image for me. I like that. It's running all the tests. I'm going to have those test containers. I'm not sure what that is. We'll just go with it. I'm experimenting. That's what we do here. I'm experimenting. I'll try to think out loud. If you've got questions, feel free to ask. works. Oh, here we go. It says unable to parse name retail store. Right, so this is the Spring Boot plugin where it gets its defaults. I think I know how to change that, so bear with me. I'm going to open up the project I worked on last time on this session. And let's see, I go on the screen. Let's just take a look at what we need to do different. Why don't I see the artifact and the name are the same? Do I need the repackage classifier? I don't think so. This is their native, which we should probably do next. Here's the Spring Boot plugin classifier. Unpack. Let's pull this in. So again, I'm just grabbing stuff from my build profile, my default build profile, and we're going to try to see if we can include a way to make that dataset util into an image. It doesn't seem like a big deal. Hey, it worked locally, so now I want to move on. I want to go past. Whoops. I want to go off my laptop. What's the next step? I think that we're past the days where the next step is oh, I got to put that repackage classifier. Why? To be honest, I don't know what the repackage classifier does. That's okay. We'll learn together. We'll figure it out. So it doesn't have one there. It's an empty value. Are we creating one here or not? So really, do I need it? No. But I might need it later for the making it a native image. Enough. Okay. Spring native. Oh, I don't need the native stuff yet. But since we're making images, we might as well bring that up too. And yeah, this is the art of copy and paste. We've done it before. Those kind of things that don't really stick in the memory. We're learning to go fast. Anything else? Okay. So let's try that. Let's put this. Let's be a little faster. Hopefully. Here I see. Thanks for joining. Zacharia, I'm not sure how to pronounce that one, but let me know if I'm close. I'm learning Spring Cloud. I read that what Spring Cloud offers, you can have it with K8s. Can you explain more why they may be equivalent? Okay, that's a good question. And one of the things that I realize is sometimes we talk about stuff, and a lot of times I make assumptions on where everybody's coming from. So one of the things I like to do is say like, hey, what does that mean? What does it mean, Kubernetes versus Spring Cloud? Even in my head, they're very different because I think Spring Cloud, that's kind of the suite of things that are provided to us by the Spring team to make our cloud native journey a little bit easier. So Spring Cloud is a big umbrella of a lot of products. Spring Cloud Gateway, Spring Cloud Config, the Discovery, Spring Boot. All of these things kind of roll up into our cloud native journey. And cloud native means different things to different people. We at some point we stopped making things robust and we started making things more resilient. We started realizing that there's going to be more failures, and failures were going to happen, and we needed to recover faster. So we have things, provided to us so that we can be resilient instead of robust. We're doing microservices, and that cloud native journey, a lot of times for me, it starts with Spring Boot and Spring Cloud. So what's the difference between those two? Well, Spring Boot, Spring Cloud, I can make this application. This is a Spring Boot app. In that Spring Boot app, for me, it has, it failed on this build, but let's step back because you had a good question. It says, hey, I can't find this. Oh, I know why, because I didn't have the dependencies, but let's step back. And I was running it. I'm going to undo my changes here. Or no, I'm going to go grab the dependency. We're going to run this. The big thing about being cloud native for me was I wanted to have all those things. I want to be production ready. So before I was cloud native, I was cloud ready. And my applications had things like health checks. And that's one of those, it's a big deal for me. But it's also a concept that you find in Kubernetes. So I'm going to grab this real quick. I'm going to grab my dependency. I think it's this that I need. I need my repository here. Oh, and I need the plugin repository. So let's just grab that. I'm going to grab those and put it into the other because you couldn't find it. So I can put those right here. I'm just going to run this one more time. And then I'll scoot back to those endpoints. So where I was, perhaps you are too, is I was coming from a spot where I was just getting my source code. The jar file was getting put into a repository somewhere, and then some other team was pulling that jar file out and deploying it. And it was difficult. It was painful for me. Let's see. AOT code generation. Okay, maybe I bit off more than I should have. So let's undo this part. So we're going to back up to where we were before we did the. I can still do my image build without doing the native one yet. So let me figure that out. I'll try it one more time. By that time, we're throwing stuff over the fence. Somebody else is taking it to production. I had no visibility in production, but I wanted to know how things were behaving. So what I started doing, why do I gotta fix it? I gotta fix this name still. I think I can do that right here. I think what I need to do is control. Let's try this. Okay, cool. And then if I make that image name, what does it want? It wants domain, host, port. Is it because of the capital? I think that is. Oops. So yeah, Spring Cloud and Kubernetes, I don't think they're equivalent. What I think Spring Cloud does is it helps you be more cloud native, and Kubernetes is an infrastructure abstraction. So uh, maybe they're both headed towards the same goals, but they're not equivalent. So I'll start there, and I'll show you a little bit of what I mean. So my image is working. I'm building a container. Can you be cloud native without building containers? I think you can. Yeah, there are ways of doing that. As long as you're resilient, as long as you're able to recover, and you're providing some of those cloud native elements, I think it is possible. But if you have more questions, feel free to ask. I'm just kind of rambling. We're taking this package, turning it into an image, and then we'll see if we can get that image deployed. And what would that do? That will make it so that my Docker Compose can not just stand up the databases, but I can stand up the databases and the application that's consuming those databases all in one deployment, much like what you would do in Kubernetes. But I would like to start where everybody's at. I'd like to make it easy. You should be able to do these things without having to have Docker, without having to have Kubernetes. But you have to have that back end, and Docker is a nice way to do it. But you shouldn't have to do it with Docker, right? You should be able to install Redis locally or install Postgres locally and run the same example. But I think the more advanced approach, once we get past Docker and doing a Docker Compose YAML that shows all the things, it would be nice to let's take that and convert it into a Kubernetes deployment or a Knative deployment, so we can run it on Kubernetes and get all those things. So my build worked. So now I should have in Docker images, should have something called retail, and I do, and that's great. So that worked. So I am going to add that. I'm going to go ahead and make that available. I think that's good. Excellent. So now back to what I was rambling about before, is I want to run my application. This is Spring Boot. There's nothing Spring Cloud in this particular example, but it's Spring Boot, the thing that I was showing before, where I could take my applications and by deploying them as Spring Boot, instead of deploying them to a shared Tomcat, for example, like we were doing, I could deploy these. They had their own version of Tomcat. I didn't have to worry about the version of Tomcat changing from under me and having to change my configs. Everything was packaged together. But even just this endpoint was a big, big deal for me, because I could go and look at those different instances that were being deployed, not in containers. They were being deployed on virtual machines or bare metal. but I had access to them. I could go in and I could see what's going on. I could see their health and their uh, metrics. I could create my own metrics, but I could see what's really happening uh, in those applications while they're running in production or in development. And this other endpoint, hard to remember all the things, um, but I could capture thread dumps while I'm working. Uh, this particular endpoint is showing me all the things that are exposed that I get kind of out of the box. I didn't have to code all of this. I added a dependency, and Spring provided this for me of just ways for me to go in and help take a look at and inspect and see what the state of my application is. And this is before I was hearing the term observability, because there's nothing automated here. But this was that first step of seeing what's really happening. Like this one, I was using the info endpoint to tell me my instance information. You can update these endpoints along the way. You can override what's provided on these endpoints fairly easily. I think I remember how to do that. Let's see. That might be a good example of, just as we grow, as we get to scale, these types of features are kind of required. And again, not every application is the same, but every application needs to have some level of visibility into its state so that we know, even if it's just health, like, are you up or down? We should have that. I'm wondering why this health isn't showing the status of my data stores. I kind of expected that to be there. And I'm wondering, let's take a look at my properties real quick. No. So I said, hey, the endpoints expose. There's another thing that I need to do for the health checks. Let's do that on screen. Expose screen root here. There's that flip that I do, not there, I'm going to the docs. And I want to do, I think it's just audit events. What I'm looking for is, again, this is the last thing I'll do. On my actuator, on that health endpoint, I have the ability to show not just, hey, are you up or down, but I can show the status of any of the backing services as well. And I want to turn that on. So I'm going to endpoint info enabled. And the endpoints enabled by default. So info is on, they're off by default. Okay. So health is now exposed on the web. Where is the health? You use health information to check the status of your running application. It is often used by monitoring software to alert someone when the production system goes down. The information exposed by health depends on the management. Endpoint health, show details, and show components. So let's say always. We're going to make those both always, and then we're going to rerun it. As this is just, I knew they were there. It's just been a while since I made them. Endpoint health, show details. always. Show dash results always. And then health, show dash components. Perfect. And hopefully this. Yeah, we got plugins. So now what I expect is a little bit more data, a little bit more info. Cool. So now I can see that not only is my status up, I can see the things that have registered their own health checks. So this is saying, hey, I've got a database here that's up, and it's saying, yeah, cool, I'm up. And I also have disk space that says I'm cool. And Redis is saying, yeah, cool. Hey, I'm wondering, I don't know what that's doing, to be honest. Do I have network connectivity? But the cool thing is those components are being rolled up to say whether I'm up or not. My status is up. So let's do a little experiment. What happens if I go and I shut down one of those databases? New terminal. I'm going to do Docker compose. This shuts down both of them. So I take my databases down. Happens. My application is still running, right? My application is still running, but oh, look, it says, hey, I can't connect. I've got something that's watching those connections, and it says I can't connect. So what would I expect my health endpoint to say? I would expect it to be down. It's trying to connect. I expect that is still running. It says reconnecting. That's cool. This is where we want to fail gracefully, but it's not. So perhaps this is what I need to do to improve it. But I want my database status to be down, but I still expect this to be up and running. Right? I can still hit this endpoint. I can still hit the mappings. I expect this. Why is this one not behaving? Is it because of those watchdogs? I need to maybe reconfigure those. But if I had something that was analyzing and checking that health check endpoint to see whether it's up or not, and if it's taking a long time, yeah, that's no good. And then I can go, I want to do another experiment here. I'm going to stand them up one at a time. Like this. Right, so now Redis is up. And let's see if the status or health has changed. Oh, so something happened. The Postgres isn't working, but this guy is reconnecting, and it says reconnected. Okay, that's cool. Oh, and then look, my health. I'm gonna hit that refresh again. So the Postgres one took a while, but my health, you can see this database is down and this one is up. Oh, disk is good. And since that database is down, I'm reporting down. So the health check for my database has a timeout. There you go. And that timeout is currently set at 29 milliseconds. Was that 300 seconds? Or is it 30 seconds? It's 30 seconds. So it's still down. So hey, it timed out. There's problems. And my status says I'm down. Now, there's more than one status. You can be up, you can be down, partially down, etc. But it all depends on your system. What I'm going to do now is I'm going to go stand up that other database. I'm going to see, hey, if my status is down, I don't want to send any traffic to it. So now I'm going to set it up. I expect, because it's Docker, it's going to stand up pretty quickly. But I expect that this endpoint becomes healthy. Not running. Don't want that request to take 30 seconds. But we'll see. Being able to recover. Sweet Killer 9. You hear a strange noise. Awesome. Thanks for joining. That noise is most definitely my laptop fan overdoing it. That's going to be my guess. But thank you so much for joining. I really appreciate that you're here. You're always welcome. It's fun. It's fun knowing that you're out there and you're watching. My endpoint is still down. I'm not sure why. I'm going to hit it again. So my database should be up by now. But this says, hey, it timed out still. Let's go look at our status real quick. So something is still... so I've seen this too, right? Where I've got a thread that makes a request. It says, hey, I'm trying to connect to something. And that thing's not there. And it's waiting for a response. Transient connection exception. Oh, is it because I'm using a pool that is not recovering quickly? And this is absolutely something that I've run into, where if I'm not cleaning up my connections properly, on cases where there's a timeout, and understanding what the defaults are for your connection pools, that can cause things like this. Because right now, clearly, my database is up. Let's just take a make sure. Yes, my database is up. Yet my health is still showing it's down. I have a database that I'm able to connect to. It's up and running. But the way that I've set up my connections, perhaps they aren't handled properly. Maybe those timeouts or the resets are not ideal. But this is what we're trying to do. We want to be able to recover quickly. So I'm glad that I did this experiment. This is something that I want to be able to figure out. Why did this not come back when clearly my database is back? And I know, well, I assume that if I stop my application and I start it again, everything should be healthy. Let me give this that one last try to finish. I think 30 seconds. And it says it's still down. My database, I believe, is in a good place. There, look at the Hakari pool shutdown is initiated. I'm going to stand it back up. Again, I'm not changing anything on the database. Those databases are both up and running. I'm going to go straight back. Oh, wait. What happened here? I didn't change anything. It's still not able to connect. Password authentication failed for you. Did I not stand up the database properly? Oh, I might not have. This is the... No, I didn't. Haha. That's why I didn't come back up. So let's try. Let's do this again. That's what it's supposed to be. Oops. Stop. I exposed all of my scar tissue in those cases where, hey, something was crazy, something was wrong. So now my database is up with the right username and password. And what we'll do is we're going to stand up. We're going to do the exact same experiment, and we're going to confirm our thoughts. Yeah, so today I was trying to take this demo, and I wanted to make this demo easy to consume. So I wrapped it up, and I added Docker Compose to it. And then I said, hey, maybe I want to build an image. So we can do that too. And then there was a question about what's the difference between Spring Cloud and Kubernetes? And I'm talking about cloud native. And this is Actuator. Actuator was a big deal. And I think it's a really big deal of what you get out of the box. Alexander says, can you connect to the DB from IDEA? Yeah, I don't think I have that DB. Oh yeah, I do. I have a database plugin right here. So let's confirm. What's happening here is it's saying, hey, you got a bad password. Did I restart with the right thing? Or did I even retry? Let's go back and look. Oh, I removed it, but I didn't restart it. So Postgres, that's what I want. Something's already running. We're going to get here. We're going to go through this example and we'll make sure that everybody's on the same page. Move. Cool. All right, so right now it's just Redis and my Kubernetes node. Now we're going to redo Postgres with the right password. Let's double check here. In my application, Postgres, cool. So that's up and running. Now, I should be able to start it here. It's looking a little bit better. And then, great idea. Like, can I connect? Here's a Postgres. And we're going to fill the blanks. Postgres, localhost, here. User is Postgres. And it's also cool. Can apply. I should be able to see it. Voila. There's my database. I didn't do a schema generation or anything, but I can do that now too while we're sitting here. So my application is up and running. What I was doing was showing the value of the actuator endpoints. The actuator health endpoint, it shows that I'm up. And at first it was just showing that I'm up. And I wanted to understand, like, what does that mean? Well, it means that my Redis instance is up. I don't know this ping health check, but I had this ability to say, hey, this component, this dependency that I'm using, it's going to provide a health check. And those health checks roll up into the application that contains them, that's using them. So because I have Postgres there, I've got this DB health check, and I've got this Redis health check, also disk space. The next thing that I did was I went over and I shut down those databases. So I'm going to go over here, I'm going to do Docker stop Redis. And I went back to my health check and I said, hey, yeah, see that it's taking a little bit of time. Like, hey, what's going on? We'll see in my logs, I've got these things that are trying to connect. And they're like, hey, I can't connect. I'm having a problem. And yeah, my health endpoint, that thing that's checking to see whether I'm up or not. Yes, there are. So Sweet Killer 9. From what I remember, there are readiness and liveness probes out of the box, starting on 2.3 for K8s to use. This is absolutely true. And yeah, and there's a difference, right? I can be up, right? But that doesn't mean I'm ready to take traffic. So this endpoint is failing. Let's see if we can find the readiness probe. Ready? Thread dump. Let's see if we can find thread dump. So maybe not. But yeah, I know what you're talking about. I just don't know, off the top of my head, what those endpoints are. But but there's a difference, right? Between being up, like in this case, my application is up, but it's not ready to take traffic. If I'm expecting that I can write to that Redis instance, it's not ready to take traffic. It is up, but not ready for traffic. So we'll go back. It's failing. Now we're just going to go back and say, hey, let's bring that database back. So things are down, cool. What I'll see here is like, oh, yep, hey. I think it shows me like, hey, I reconnected after a second. But we're going to go back here and we'll hit our, oh, where did my endpoint go here? Up, up, up. Everything is back up. And my status says up. Cool. I expected, oh, there it is, reconnected. So this is what we were trying to do. But now we're going to do it with the Postgres, right? That was the one that was mentioned before. So let's do Docker PS. We're just doing the same exercise. We're not doing anything special here. We're going to say Docker stop. And then things, it's like, hey, it's checking. We're going to go hit our endpoint. And it doesn't seem like this is a big deal. It's just that I got it out of the box. I could put it with all my applications, and I had a consistent way of checking how things were running or working. So whether this is a database or it's another service, like maybe I'm in an organization where I'm depending on some other service within the organization to be up and running, like the one that's taking data off of the watches. And if I can't do that, if that's not there, then hey, maybe something's wrong. So here, it timed out. I can see, let's see, Redis is up, but now I've got the information. So when the customer comes in and says, hey, why are things not working? Well, I can see here. I can go look. I can be checking those endpoints. And I can tell now, even though I've got a lot of dependencies here, or more than one dependency, I can see which one to focus on. I can see it's not, I don't have to worry about Redis. I have to worry about this one, whether it's that database or that other service. I get that out of the box. And that was a big deal. And this is cloud native. This is one of those things that you kind of need in order to deliver microservices. You need to find out where are things broken, because when we were delivering those massive ear files, rarely, if ever, was there anything like this delivered with it. So yeah, this is how we're kind of growing as an ecosystem, as a community, to try to build better software faster. And it's really nice to get these kind of things out of the box, because if we go back and look at the code, I didn't do a whole lot here. Yes, I did configure some passwords and how I want my databases to be created. But I didn't do a whole lot. And that's just config, right? That's something to get from my environment. I set up some endpoints. Again, not code, it's configuration. And they're same defaults. If this wasn't there, your management endpoints are going to be turned off. You don't want that stuff deployed to production. And really, like, just to revisit the code, I've got a controller. Like, we've done the REST controller thing for a long time, but it's an annotation. I'm loading a couple of repositories and I'm creating a couple endpoints and some ways to get data out. I got some domain classes, which this gets even easier with records. I should probably do that example next too. But we're extending from the same data model and we're just setting it up so it can be stored in two different data stores. So it's the same object coming in, but I can write it into a Postgres database or both. Redis, the repository interfaces, not a lot of code here, but because I added these Spring dependencies, I got a lot more out of the box, right? I didn't have to do a whole lot of jockeying to configure the connection pool. I got same defaults for my connection pool. The actuator get all the benefits of the actuator, including the metrics. So it's not just are you up or down? I've got these other things, right, that I can go and peek at. All the metrics that I can get out of the box. Because I'm using a connection pool, I get these. Let's go ahead and hit one of these endpoints so we get some metrics. This is a 6 megabyte LTZ file, and it's loading it. But what that should do, oh, it didn't finish yet. So I won't get it. Oh, but I can do this. The other is I have a load by ID, get JPA by ID. And even if it's a failure, that's okay, right? Get JPA by ID. Yeah, no, it's not there. I'm just trying to put some metrics into this thing. That's the right endpoint that I called. I gave it a string ID. That's cool. It should just fail. Why is it taking so long? Because on the JPA side, yeah, it wasn't there. So now I should have at least one metric. Oh, because I didn't expose them. I think is the problem. I didn't expose them. So yeah, but this is it. This is the cool stuff. This is what I get out of the box, and this is the kind of stuff that made my cloud native journey that much easier. Oh, I stopped Postgres. That's why that one took so long. So then they're all the different things that I was on. That's my health plan. It's like, oh yeah, you're down. I see that. But if I go Docker start, bring Postgres back up, so things are working properly. There. It's up. We're back. We're back working again. I can go back to this. It's gonna say, hey, yeah, cool. Nope, I didn't get that. So now if I do metrics, oh, I didn't turn those on yet. But yeah, we're good. All the things that we get out of the box. And the actuator is just one. It just happens to be my favorite. So I went over time a little bit. I did push this repository out so you guys can take it for a spin. That's here. I did make a couple edits. One of the next things that I would like to do, I think, is set it up so it's got some automation and then pull it into that local Tanzu Community Edition deployment that I set up at the beginning. But great questions. Oh, wait. Alexander says, I have a question related to your previous code session. Can you show how to create a custom image builder? Absolutely. So I kind of mentioned that one here. Let's pull that up. So this is, I believe, what you were talking about, where I was creating a custom builder. So the idea is easy, but I will definitely do this. So I'm going to go to buildpacks.io, and in their docs, they have a setup for creating a build pack. Here, this is a great place to start, and this is exactly what we're doing, is creating a build pack. I actually haven't done the Kata Coda yet, but I've gone through these steps multiple times. And when I say that, I will show you one that was the coolest. Or did one for COBOL. So like COBOL, who's doing COBOL? Well, remember back in the beginning of the pandemic, they were running out of COBOL programmers. Virginia or somebody was like, hey, yeah, we don't have enough. Sorry, your unemployment checks are being held up just because there's problems in the system. We can't find any COBOL programmers. So I took that and I said, hey, let's figure it out. And I went and I built a cloud native build deck. I'm coming from this cloud native journey, and I was trying to help customers, and I was also trying to learn. So I just kind of went through the steps to build a cloud native build pack. What does that mean? It means I could pass in COBOL code to my build pack, and my build pack would give me a Docker image, an OCI compliant image that would run that code, that would execute that code. So yeah, it can be done for any way, shape, or form, or not any, but to create these compliant build packs that you can run across systems. And the build pack idea is great. And maybe you've heard Cora and others talk about it as well, where if you're using Docker files, you got to maintain all those Docker files. But if you're using build packs, especially if you're getting ones from upstream, you get SLAs, you get the latest and greatest, all the JDK hooks and stuff built in, so you're not copying these Docker files across your organization. There's consistency. For the people that are in ops and security, they're going to care a lot about that consistency and visibility. They can know how things are being ran in production. So to go back, this is the best place to start, is the Build Packs website. But if you've got specific questions, let me know. I can kind of review what I've done here. So let's jump. The idea was I wanted to, just like I did build image for this guy. I think I can stop these now. I can say on the top, it eats up a little bit of my processor. Let me just stop these guys. Grab this one, shut that down. I get better at being able to type and talk at the same time like Josh does. I'll work on that, I promise. I was able to do on this application, on this code base, what I did during the show is a regular Spring Boot image is what we get out of the box these days. That's the thing. And what it's going to do is go just create an image. Now, it's not doing a native image. It's just doing an image. And it's using, I think I put it in the file. It's using to do that this builder, the Keto Build Packs Tiny Builder. And I flipped the flag that says, do not do a native image. So this is cool. But I also like to do a lot of stuff on Raspberry Pis. So I kind of went down the path of, hey, I need to do this on Raspberry Pi. How do I do that? And I got help. I got lucky. I was going down the path of setting up these builders and doing everything manually, but luckily, a good friend, coworker, had done a lot of this for me already. Went down the path of compiling pack for ARM64. So I could do these builds on ARM64 hardware using pack, which is a great kickstart. So what I had to do, I will show you all the bits and pieces. I have created, let's see if I can find the names. But I have all those repositories here. And I also have, let me see if I have a link. I did a little write-up on it. Oh, I know what's that. Yeah. There you go. There's one. It's also on Hashnode. But it goes through those steps. So it's another option for a quick path to building this particular build pack. Start here for sure. If you're trying to do the ARM64 route, definitely take a look at this, because it's really just a side-by-side example from what we're doing here, along with the steps of creating those ARM64 binaries so you can run it. So hopefully that helped, Alexander. But I'll also show you, I had those builders created. Yeah, here's the steps. Here's the exact steps that even includes, again, it's just my fork, where I don't even know if I made a whole lot of changes. Oh yeah, I did. I was changing the versions. I was using newer versions of some of the dependencies to build my stack, if you will. So hopefully this helps. And even more so, hopefully we get some of these ARM64 builders provided and maintained. Now, Alexander, because you're a part of this community and you're awesome, you can feel free to reach out. I would love to pair with you on this kind of stuff. Like, we can walk through this. It won't take us too long. I'm pretty sure I could fit it all into another hour session of just like, creating that ARM64 builder from scratch as a good example. Something that's not available upstream, but we can do our own custom build. What's another process? Where's another example of when you might want to do something cool in a build pack? One of the other examples that I've seen or heard of is maybe you're signing all of your artifacts. For your enterprise, things want to get signed in a certain way. You can make that a part of your build pack as well. So the resource is generated, still it's going to work. It's going to follow those conventions, be able to run on Heroku or Kubernetes. And yeah, you can still get the same output, but you can add your own custom things on top of it. And that's one of those benefits, right? Have consistent path to production with consistent known artifacts. So yeah, just an example. I think there's many ways to do these things on our way to the cloud. And yeah, these are just some examples, but I am a big fan of the ARM64 stuff. So another path is I'm trying to do this Tanzu Community Edition with a multi-architecture cluster where my ARM64 nodes will take the ARM64 workloads, but it's all going to be based on a regular Tanzu Community Edition cluster. So stay tuned for that. We're growing. I've only been here for a couple of months. We're back at VMware for a couple of months. I got a lot of exciting stuff in my backlog, and I think we're going to have fun. So I appreciate you guys for coming. I'm sorry that I took it a little bit longer than I was supposed to, but I don't think that there's anything else coming up behind me. Thank you so much. It's been fun. I'm always having fun, but you guys know where to find me. I'm at DaShaun on Twitter and GitHub and GitLab. Like, reach out if you've got questions. I will also pitch Dan Vega, another teammate. We started doing these office hours. We did one on Monday, and we didn't do it on the Tanzu channel. We're just kind of like getting the rust out, getting the kinks out. But the idea is having a place, a regular time and place where you can bring your spring questions and get help. Not just from one, but from both of us, where we both have different backgrounds and skill sets. We might be able to help answer some questions. I would love to see you guys on one of our office hours coming up. We just did one on Monday. Hopefully we'll do another one soon. I'm hoping that it's more than once a week, but would love to get your feedback on something like that. Let us know. Yeah, it's been fun. Thanks for joining, and I hope to see you again soon. Take care. Spencer, office hours. Yeah, it should be special. One of the quotes was like, "Hey, if you were doing this dance where we're migrating, from, I think I started on 1.17 is when I came into Spring Boot, but I was always trying to stay current, and if I wasn't staying current on those milestone releases and I was waiting until the next version, sometimes there's a lot of stuff going on. I had no understanding of why. So there's some value in just kind of reviewing those release notes as those milestones are coming out. There's some value in knowing when things are coming out. Like I've introduced to calendar.spring.io in the last office hours. Like there's value there. And I think an opportunity to just go out and show here's what it looked like before and here's what it looks like now, as just like a way of getting that out instead of having to go and keep track of all the release notes. Maybe we can do a little bit more proactive sharing of some of the differences and deltas, just like Dana's been doing with Spring Boot 2.6. So I'm excited. I think we have a lot of opportunities to do things on that. So yeah, stay tuned. We'll keep you posted. Take care.